In this video, we're going to look at the difference between mass and weight. If I were to ask you, how heavy are you? You would stand on a bathroom scale, look at the reading, let's say it's 30 kilograms. This 30 kilograms is actually your mass. Before I explain to you what a weight is, let me just quickly explain to you what a force is first. So a force is a push or a pull. So we would use this unit called the Newton to measure how strong this force is. So for example, if you apply a force of 10 newtons, it would be stronger than you applying a force of, let's say, 3 newtons. So it's just a way for us to measure how strong a force is. So you it's a bit like me asking you what is the distance between A and B. Well, you would say, oh, it's 7 meters. Well, this meter here is a unit of distance. Well, this Newton thing here is a unit of force. It's just a way for us to gauge how strong a force is. It could be strong or it could be weak. So going back to here, weight is actually a force. Weight is a force. So you standing on top of this bathroom scale, you're actually pushing down on the bathroom scale. You're applying a force downwards on the bathroom scale. So you simply standing on Earth, you're actually applying a force. You're actually pushing against the ground. And when you come to do this in school, your physics teacher will tell you that force is the force you're pushing against the ground is actually mg. So your physics teacher will explain to you, will explain this to you. Well, gravity. This here is gravity. We will look at gravity another time. But gravity on Earth is 10. Gravity on Earth is 10. So you're actually applying a force, a downward force. Just you simply standing there, you're actually applying a force, a downward force. Imagine you've got a chair and another chair here. Imagine placing a piece of glass and it's standing on top of that glass. You're actually applying a downward force and you would break the glass. So don't try this, it's very dangerous. So you simply standing there, you're actually applying a downward force and you would break the glass. So looking at this, hang on. So when you stand on top of the bathroom scale, your mass is 30 kilograms. On Earth, gravity is 10. On the moon, gravity is a lot weaker because it's smaller and lighter. We will look at gravity another time. But gravity on the moon is only 2. It's around 2. On Earth is around 10. So your mass here is 30. Well, weight is your weight is actually a force, and it's your physics teacher will explain this to you. It's m combined with gravity. So your mass is 30 kilograms. Your mass is 30. For you to look at the weight, you have to combine weight and multiply it with gravity. So you would get 10, multiply it with 30. It would give you a force of 300, and we would use this unit, the Newton. It would be 300 newtons because weight is a force, and this is a unit of force. So mass is 30 and your weight is 300, and it's newtons, 300 newtons. This is kilograms. So you being on the moon, your mass will always be the same. No matter where you go, your mass will still be 30. But if you're on the moon, your weight on the moon, the force that you're pushing against the ground, is actually whether force equals mg. So your mass is 30 because you're on the moon. Gravity on the moon is 2. So you need to put this 2 into the g here, and you need to combine the 2. So it would be 30 times 2, which will be 60. So your weight is 60, and your weight is your force, and the unit of force is newtons. So it's 60 newtons. So you being in space, so if you try and remember, in space you're just going to float about. So if you try and weigh yourself in space, you're just going to float about. The bathroom scale is just going to float about. And the force, you're not actually pushing a force on here. Well, anyway, your mass in space, you floating in space, your mass will be 30 kilograms. It will still be the same. So wait there, F equals mg. Remember, your physics teacher in school will explain this to you. You've got to put the 30 into the m, and gravity in space is actually 0. Gravity in space is 0. There is no gravity in space. You're just going to float about. So you've got to put 0 into the g. So now you've got to get 30 times 0, which 30 times 0 would be 0. There is no force in, you're not actually applying any force to this bathroom scale. So your mass in space is 30 kilograms. Your force, your weight in space is actually 0. Your weight will be 0. So going back to here, on Earth, your mass will be 30. Your weight will be 300 newtons. On the moon, your mass will be 30 kilograms. Your weight will be 60 newtons. So when hang on. So your mass is 30 kilograms. Your weight is 300 newtons. So when you go to the hospital and your doctor gives you a form to fill in, and on that form it normally says weight. What the doctor is asking you to fill in here is actually, the doctor is actually asking you for your mass. So this is a thing that society gets wrong. They want to know your mass, but they always use this word weight to refer to your mass. They shouldn't use, by right, they shouldn't use weight. They should use mass. But in the whole of society, use the word weight to refer to your mass. So when you see this on a form asking for your weight, they're actually asking for the mass. They shouldn't be using the word weight. They should be using mass. But it's just everyone, people who don't really understand the word mass, so they use the word weight. So when they ask for your weight, they're actually asking for your mass. So put 30 kilograms in here. Even though it's wrong, it should be, they should use the word mass. But it's just what an average person gets wrong. Okay.